Okay, so ladies and gentlemen, I'm looking forward to hearing from you this afternoon. But this morning's or this early afternoon's lecture is on a topic that we discussed last time, which is going to be very important for your successful execution of the projects for this course, regardless of who your stakeholder is. Very important component for building the right system is understanding what system needs to be built, and that involves a back and forth with the stakeholder as to what is needed, what is possible, and what would be the best realization of that. So I noted last time that requirements are criteria that have to be satisfied by a successful project, and this sort of requirements elicitation we're talking about is an attempt to discover what product is desired by people in light of the user's hopes, constraints on the technology, constraints on the team, what's readily available, etc. And I noted that requirements elicitation is ubiquitous. We have to undertake it for a very large number of types of projects. And it's oddly hard to do most effectively and extremely important. And I noted that requirements have a pronounced place there in the set of issues that cause systems to fall short of their potential, and that in fact drive system development dysfunction. So cases where development projects don't work out well, often it's because of issues with requirements. Sometimes the requirements are not understood. Sometimes they are understood but keep on changing. Sometimes there are conflicts in requirements between multiple parties. You have different stakeholders who have different visions, and it leads to challenges in delivering on those visions, etc. And I noted that, if you could put aside needs to understand requirements and started the project with a sort of clear idea of what's wanted, often the cost to develop the system is far less. And I noted that requirements affect all three areas of this iron triangle that characterizes software development. What are the three components of the iron triangle? Do you remember? I mentioned it briefly last time. The iron triangle in software. It's a common term in some areas of industry. What are the three sort of components of the iron triangle? Three vertices. I'll tell you one. One is dollars. The cost of the project. What's another one? Time, yeah. And the other one will vary from author to author, but typically it has to do with some combination of scope, quality, or combining both of those. I'd prefer value delivered to the stakeholder. The idea here, the iron triangle, is that it's really easy to do well with respect to one of these if you don't have to worry about the other two. It's actually not very hard at all to do well with respect to two of these if you have flexibility in the third. But it's very, very difficult to do well with respect to all three. Getting your system in within the budget constraints anticipated, within the time frame hoped, and within the degree of value delivered, the level of quality and scope is often very challenging. This is why it's called the iron triangle, because often one can accomplish two of the three easily, but three of three is awfully constraining. It's very difficult to do reliably. And a lot of the best practices advocated in this course and practiced in industry reflect that. So I noted last time that good requirements affect all three components of the iron triangle, all three of the corners, the vertices of it. They affect the scope and quality of value delivered. After all, if you're not building what the user really needs, you're not going to be delivering much value. It also impacts time, because if you don't have a good understanding of what the user wants, or if that understanding is changing because the user needs are changing and you get new updated requirements, often it's going to take a longer time to develop, and along with the time typically goes dollars. Typically goes the budget. And I noted last time that there's a variety of issues that lead to problems with requirements. One of them is ambiguity. Another is incompleteness. Incompleteness is a particularly pernicious one. There's two common reasons why a requirement, an actual requirement, might be missing from your list of requirements. What are two reasons, two very different reasons why it might be missing?
It wasn't gathered from the stakeholder.
Okay, so it wasn't gathered from the stakeholder, and there's suppose you have meetings with the stakeholder, and that doesn't come up. One explanation for that is that it might not be important to the stakeholder. It's not an issue. It doesn't come up because it's not a requirement. It's not in fact, needed. They don't care about it. But there's another very common reason it might not have come up. That's very common. It has to do with often the fact that they're coming from a different background.
It is seen as impossible.
That can be, and actually, in my experience, that's not that unusual that a stakeholder doesn't request something because they think it's so unlikely you could deliver on it that they don't even bother mentioning it. Whereas, in fact, with today's technology, it may be that, in fact, you could deliver on it, and it would be very valuable if you could. They just don't mention it because they don't think it's in the cards. But there's another reason, too. Yeah?
I thought of it as self-explanatory, obvious.
Yeah, exactly. It's just so obvious it goes without saying. That they're not going to say something, they're not going to think to say it because everyone in their area knows this. And surely you would know this thing. And unfortunately, that's not that uncommon, that they'll just assume you know this. And believe me, it's the same thing in reverse. We think all the time the stakeholder knows certain things about the technology. Like a distinction between RAM and what's on persistent storage, right? Or the fact that with phones, with smartphones, we can't run as CPU-intensive tasks for long periods of time as we could with a computer plugged in, or that Wi-Fi is slower than Ethernet. These things may be very obvious to you that programs on an app on a smartphone needs to run in a more memory-constrained environment than a similar one on a workstation. These are things which we just come to understand and appreciate. And when you hear someone talk about a smartphone app, there's a lot of things that come to mind. A lot of things that come to mind with that to a stakeholder, won't be obvious. So incompleteness is one of these things that's unsettling because you don't know where it ranks in there. If you omit requirements, it's really hard to deliver on them. And these are often some of the ones that it's hardest to make sure you get right because they're not even recorded, right? You can get conflict between different stakeholders and different priorities associated with them. Different ones are mentioned at different levels of importance. Sometimes developers come up with their pet ideas of things they'd like to see, it would be cool, etc. Another thing is, and this gets to my tips later on, if you have two people that attend from the team side for a stakeholder, they may hear two rather different things. They hear different things and they recall different things potentially later. Very common. Very common. Their familiarity with the terminology or their understanding of what motivated a comment is not clear. I noted last time that most requirements are actually not customer requirements. They're not going to be told to you by the customer. They're going to be implied by a combination of what the customer wants, the state of the technology, the state of what we can accomplish computationally, and a lot of these relate to sort of how the system needs to be run. I'll throw out an example. For the Oculus project, running on Oculus, we need to take advantage of GPU pipelines, the graphics processing units, to get decent shading performance that will scale it up to, say, tens of thousands of data points. Doing things above hundreds of thousands of data points probably leads to frame rates to be very slow, to the point where people will, if you go above a certain high hundreds of thousands, people literally make it seasick in Oculus. It's a known effect, and it's worse in some people than others. Our stakeholders typically not going to mention this to you. It's something you got to know because you're working in this domain. Just like the characteristics of smartphones or the characteristics of cloud-based computing or what have you. If you were, time was, this is no longer true, but time was if you were working with FPGAs, field programmable gate arrays, then you have to do fixed point arithmetic. And again, a stakeholder's not going to know these things, but if you want to deliver on their needs, you need to know about them, and missing them can be really problematic. If you design something to run on an app that assumes perfect ongoing connectivity, that it's able to connect to the server at any point to sync data, etc., you're cruising for bruising. I mean, you're putting yourself in a bad way because you can't assume that reasonably. There are times where smartphones lose their connection. There are times, handoff times between ports, times when they go into airplane mode, etc. A lot of these derived requirements are things we have to bring to the table as software engineers. Now, there's a distinction between functional requirements, requirements that have to do with the behavior of the software in a way that relates to sort of the features of it, and non-functional requirements, of which there are typically many, but many that are not explicitly requested by the user. Now, with functional requirements, the need for features, the need for how to most effectively address the hope for functionality of the system, the hope for behaviors of the system. The challenge here is that there's asymmetries. There's challenges on both sides. Okay. On the client side, on the side of the stakeholder, typically, particularly if they're not from a technical background, if they're not from a computer science technical background, it's very difficult for them to envision a solution. This is, again, something we as computer scientists, it almost goes without saying. We are just constantly immersed in different types of interfaces. We're working up in Sphinx Lab. We're pursuing an assignment for cloud computing or for CMPD 350. We are using dev tools on a laptop. We are using our smartphones, what have you. We see a massive number of different types of user interfaces. And because of that, it gives us a repertoire, a kind of toolbox to think about that is actually quite broad. We've seen a lot of different ways of dealing with something, and you will sometimes be able to reflect back, oh yeah, I've seen something like that before. I've seen this interaction of drop-downs and and radio buttons in a different context. Or I've seen a really interesting way of scrolling in 3D in this fashion, or rotating or what have you. And it's easier for us to understand what possible solutions might look like as far as kind of UI elements. But for a client, they may be spending their life in Microsoft Word. Yes, they have an iPhone and they use that, so they've seen a certain amount there. And a defined set of websites, and they're not going to be able to envision the solution often with quite the repertoire we can. They know they know where the pain is between what they can currently do, what they'd like to do, but they have a hard time communicating the domain understanding behind it. Gary Groot, he's a surgeon, right, here in town. He's serving as a stakeholder for some of you. He knows things about the surgical context and the context of meeting with patients post-surgery and the needs of those patients that no one in this room, including myself, really would fully grasp or appreciate. And if he were to try to characterize that to us in a brief meeting, communicating these things is hard because there's all these terms that doctors will use, clinicians will use with themselves and with various other health professionals and allied health professionals. If they're talking with a nurse or they're talking with a physiotherapist, there's certain terms they use to describe the situation very concisely, very succinctly, and you know what it means. You say this patient has a failure to thrive. It means something quite specific. This patient is decompensating. It means something quite specific. This patient has issues with compliance. That means something very specific. I happen to know a lot of these terms because I work with a lot of them, but the fact is, for most computer people, they're not going to know what these things mean. A client is not, and this is key, and it relates to Eric's point before, they're not going to be aware of what's feasible. And they may sometimes think things aren't feasible that are, but what's a bigger danger is that they think something is feasible that isn't. And believe me, I get that a lot. A lot. And that's a big issue because ladies and gentlemen, one of the biggest principles for success in these sort of software is actually something that's not on the syllabus, and I just assumed it because we know these things. But let me just state it, because it should be on there. It's managing expectations, setting expectations in line with what can be achieved. Let me make this point a bit finer. So the issue is two projects in mirror worlds. One project, in both cases, the same system is delivered. In one case, the stakeholder is expecting something of similar or more constricted functionality. They don't expect something as fully functional, as quick to operate, etc., as what you give them. They are one happy camper. Right? The other world, they have expectations for when it will be delivered that are quicker than when you've delivered it. And they have expectations for the functionality and the speed of the system, sort of the responsiveness and the usability that are much tougher to meet than you've been able to achieve. You deliver that system, same amount of time, same functionality, same cost, etc., same responsiveness, and they're a very unhappy camper. Maybe they're crying either. So managing expectations is as much part of a successful project delivery as managing the actual delivery of technical artifacts, the technical deliverable. same deliverable, very different reactions based on their expectations. And so cluing them in, and frankly, under-promising and over-delivering is often the driver for a successful outcome. Not that you're producing something better for them, but you're producing something that they're happier about because they didn't anticipate that it would be as good as it is. And if you think that's arbitrary and unfortunate that where the action's at should be on the technical component, I have some sympathies for you. But we live, ladies and gentlemen, in an imperfect world. What's worse than this is that we are called to account all too often as software developers, and called as if we have failed when we can't meet expectations that are patently unrealistic because no one consulted us. And one of the worst issues is with respect to scheduling and estimation of the length of a project. Do not take someone else's statement that the project needs to be done by then, and you will be done by then, without even listening to you as to how long realistically it's going to take, because it's setting ourselves up to fail. That project may be declared a failure, not because it falls short in any material way of its technical promise, but because it was arbitrarily decreed that it should finish in 6 months instead of 9 months, and then you're judged as a failure because it took 7 months. And unfortunately, this happens a lot. And so managing expectations is key. And with your stakeholder, you will want to manage expectations. And often, you may think that they'll be really disappointed if you tell them they can't get something. But if you tell them up front and they learn to expect that and so on, they may be, they can take that into account in their planning. What's really problematic for them is when they expect something that's not delivered, and then they've been counting on it, and it's a very serious situation. After all, they don't have the solution now, and if you go a long way towards part of the solution, they're a happier camper. If you promise them the world and then don't deliver on it, they've built their world around counting on that potentially, and then you're not able to deliver it. Now they have to really replan, and it's a big pain. Okay, so the client is not able to understand what you will be delivering, and they don't understand the logical steps that have to be taken to get there. They don't understand the steps that you have to go through in a structured way to accomplish something. So maybe what they want is an app. They want an app for multiple public health nurses to be in sync while they're in the community conducting contact traces. They're trying to find people who need to be brought in for testing for TB or some other nasty infection. And they want me to know, okay, if this nurse has found this person, she knows if I found him, as we try to locate these various people. The stakeholders know that requires a server, and that requires exchanging data, requires the capacity to communicate between these folks. And so the logical steps that you have to set up some sort of server infrastructure, or you have to make use of something like Firebase to exchange information. It's not clear. And they may not know why you're getting involved with cloud stuff when all they want is a lousy app, but it follows. It follows from it the ability for me to know what you're doing, etc. And they don't understand the technology implications of the steps. Okay. Now the technical team. So this is a position of for the client. It's a position of vulnerability. They don't know a whole lot of things that they need to know. But for you folks, from the team's perspective, it's also vulnerability. you don't really clearly understand the domain-specific need. You don't really know what exactly Dr. Groot is looking for with this app, and the nature of the patient support needed or what have you. And you're counting on him to explain it in terms you might not be familiar with. You don't appreciate the gap between what's now and what's sought, sort of where the pain is right now. What you can do now with existing tools and what is desired. Now, generally, you can more clearly envision it at certain elements of it than a client. You have a better repertoire of kind of things in the toolbox for how things could work. But you still can't often envision the solution before you get it in front of you. Get a straw dog in front of you. And it's hard for you to understand the language being spoken to you by the stakeholder. You may think you understand it, but you actually understand it wrong sometimes because you're taking a term in a colloquial sense that is actually a technical term, or what have you. So functional requirements elicitation is very important. What does the system need to provide as far as features? And generally, in many cases, this includes several components. You say who. What sort of person is this? The doctor is a administrative assistant to the doctor, or a nurse or a patient. Should be able to do something to some information, say, in the system, and you may have a qualifier in there as to sort of within a certain amount of time, or without much effort, or very quickly, or what have you, and you may specify use cases. Do you folks get exposed to use cases? Where did you see use cases? 370? Okay. Do they get introduced in 270 these days? Okay, 370?
Yeah.
Okay. Did you go into them quite a bit?
Yes.
Okay. So they are valuable for many functional requirements because they capture elements of this, right? They capture the user type, doing certain things to certain components of the system, etc. Very useful, not exhaustive. Now, there may additionally be things over here from the systems perspective and sort of conditions under which this is possible, or results, what is performed as a result. Example, and here's some examples, right? Example requirements. So all network transmitted data that includes health information shall be encrypted using 128-bit RSA. That's of course the encryption algorithm. Encryption. A user indicates search and replace is needed. The software responds by prompting for a search term and replacement text. The user enters the text and indicates the software to do case-sensitive search to replace all occurrences. Now you'll notice what this includes and what it doesn't include. It includes a description of sort of what you can accomplish, but little description of how. In other words, it's not saying that they press Control F to do the search, right? It doesn't even say they use a menu item. It doesn't say they push on a certain button. It just says they indicate that it's required, right? It responds by prompting them. Is it like with Kate, something down at the bottom of the screen? Is it with a dialog box? It doesn't say. And that's by intention. It's to keep these high enough level that they don't get into the weeds of the software. That's design. This is requirements. Okay. User enters text, indicates it's to do a case-sensitive search. How do they indicate that? Is it a checkbox, a radio button, or what? Left unspecified to keep the requirement as general as possible. So these are some example requirements. It is very important that the requirements be such that a user could read them. A stakeholder could read them. Because otherwise, they're produced for the team, but you're not checking back with the stakeholder. And again, checking with the stakeholder about their interests, their understanding, and that your understanding is in line with theirs is very important. So I note its use cases are not the be-all and end-all. If there's complex series of conditions, if there's certain algorithmic details associated with things, it's not going to be well expressed in a use case alone. They're not necessarily going to give developers an integrated picture of everything that has to go on. Developers often have to piece together an understanding, and if there's components, tasks of the system, elements of it that are not user-facing, they tend not to be as favorable for communicating those. But they're very useful, and I would love to see some use cases. I would love to see some for this class, for some deliverables. Okay? Now, those are comments about functional requirements, which is really where use cases come to the fore, etc. There's this whole other area of non-functional requirements, and these run the gamut between things that very much affect the user experience. I put up here performance, usability, scalability, as first and foremost there, indirectly robustness to errors and security. So these are aspects that are not typically specified in kind of these types of statements about a particular user being able to do something. But more than that, there's additional non-functional requirements that have to do with more technical layers of understanding, and that often have to do with the software evolution, like the flexibility of the software for future development, the code quality, security of it, reusability of the code, and then some, also that affect user experience, availability, reliability. Is the system up 6 nines, 99.999999% of the time, or is it 4 nines or what have you? It might be specified in terms of availability. And there might be certain platform limitations that come about because of the character of the devices, say a smartphone being a case in point. Okay. This is what I really want to emphasize for you, because I want to give you some tools that will help when you go out and talk with stakeholders. Yes, your initial meetings, but also your meetings through the semester. Okay. So you're going to be gathering an understanding of what the system has to do. And as in so many things in life, it behooves you to be conscious and consciously wary of and thinking about the dangers that are out there. The world is a dangerous place. World is a dangerous place. And it's dangerous in terms of requirements, misunderstandings that cause egg on your face or cause stakeholder dissatisfaction, cause the system to fall short of its goals. One way to, so much of what we do in software is to manage risks at some levels. Risks of change, we put in place certain abstractions that will allow us to handle changes like that very quickly by just changing parameters for a function call, say. We put in place mechanisms in terms of our builds to make sure that if bugs come up, we spot them as soon as possible. Here, we're trying to head off, we're trying to reduce our vulnerability as part of effective risk management, as it were, our vulnerability to some of the misunderstandings I've just been talking about. So one thing is to repeat understanding of requirements back to the stakeholder. If you think you get what they are saying, great. So state it back to them in your own words. Rephrase it in your words, because parroting their words back to them will not be so helpful, because they may be using a very specialized term that they know exactly what it means, you don't know what it means, and you just parrot the word back to you. It's not much better than a parrot saying that. You may not know what the word really means. So you rephrase it into your words, and it will come out less eloquent, perhaps, than how they phrased it, but more to the point, you'll spot if there's a misunderstanding more with greater reliability. So say things back to them. Okay. Another thing you could do is ask the stakeholder to repeat something. Could you say that again? Say that again. Could you repeat that? Could you repeat it in other words? Ask them, could you state that in a different way to make sure I understand it? Maybe they'll realize, oh yeah, I was using jargon here. And they'll start to, say something in different words that are more communicative. A key thing, and I think it's on here, but an absolutely key thing, ladies and gentlemen, if you go talk to the stakeholder, there's one person who should be along for most or all of those meetings, and that's the project manager. But do not just send one person. Project manager alone, for example. Have at least several people. Why? Why do I say that? Yep.
Different people will remember to ask different things, to understand some more things and clarify other things.
Good. So they'll ask different things, and that's key. They'll also hear different things sometimes. And that's really important because sometimes with one person, they'll come away with a clear idea of what's wanted. It's clear and it's wrong. And you got several people and you realize, wait, there's a confusion amongst us. Francis Bacon once said, the great sort of philosopher of early science, 1650, I think, once said that truth comes more quickly out of error than from confusion. And what he actually meant is basically that century's version of fail early, fail often. So if you have an understanding of what they say, if one of the people there, come out with it, even if you think it may be wrong, it'll more quickly lead to a correction than if you just didn't say anything and you go back and are confused amongst each other. So if you don't be embarrassed. This is how you learn. The stakeholder will often really value the fact you've asked this important question. Requirements documents are living documents. They should evolve over time, just as understanding evolves over time. They should evolve because requirements change. Changing requirements is one of the biggest reasons for project failures. But they also evolve because our understanding of what needs to be captured and how to express it changes. So be sure to have those, an evolving document. It's not something you build for deliverable one and then you move on. Ladies and gentlemen, requirements traceability. Keeping track of requirements traceability is something you should think seriously about. The idea here is, ladies and gentlemen, requirements drive many components of a project. We talked about it before, right? Requirements drive the design of the project. You need this feature. I need to be able to search in this way for this information. That drives design to keep an index of different occurrences of that and to have this, these dialog boxes available and capacity to invoke them and so on. Drives aspects of the design, drives aspects of tests, of code, and reviews that have been conducted. And if a requirement changes, it will often drive changes in these things. If you are keeping track of which of these things are dependent on a given requirement, which of these components of the system were caused by this requirement or driven by that, it's a lot easier if that requirement changes, to sort of figure out what tests need to be rewritten, what code. I hope, I anticipate, nay, I require that you have in place UI tests as part of this course. Not all tests are UI tests. Manual testing, automated testing, not through the UI are extremely important. But UI tests are very important. in this class. And UI tests often have as a key component the fact that they test use cases. They test certain functionality. And if you go and you change that functionality, you will probably have to redo some of those tests, rewrite them, alter them, write new tests for the new functionality. In any case, tracing or keeping track of which tests and which code and design stem from which requirement is a laudable practice. This is not something I require. I absolutely require. But it's good with a capital G. Prioritizing. Have a sense from the user. Would you say this is a higher priority than that one? Could you help us organize by sort of order which you see as high priority, medium priority, low priority? This is a thing called acceptance tests I talked about before. They're kind of the highest level of testing, and they confirm the requirements have been met. And in some industries, you have to have the parties who are accepting the system agree on the requirements tests, the acceptance tests with those creating the system, et cetera. So you have these two parties, the users and consumers, who agree on acceptance tests. I would look at these are typically UI tests, and I would look, to you to have some of your UI tests certainly at that level, even if they're not explicitly acceptance tests. Right. So think about hidden requirements. What is not being said here that might be being assumed? Listen in the stakeholders' comments for things that they're not coming out and directly saying, but which are assumed behind the scenes. Let me give you something that I find very rarely. Yeah, I'll give you just a second. Let me tell you something that's very often overlooked. Okay, we go through this an awful lot, more than you should probably know. And one thing that's very commonly overlooked by users for a system is the necessary administrative side to a system. So they typically, in my experience, stakeholders think they focus on, almost to the exclusion of everything else, the end user experience. They're thinking about the person with the app who is using it to enter safety incidents. They're thinking about, the person who's using the website to gather information about resources in their community or something like that. What they're not thinking about is who has to maintain this information, who has to enter it, what's the interface like for people who need to, provide passwords and delete passwords. For them, they don't know. They don't know what goes on there because they're not IT folks. They don't know what. All they know is that stuff gets done, right? Somehow passwords get assigned and revoked, etc. Somehow information is maintained on the system, and they don't quite know what the interface is like. So the idea that there should be an administrative interface for administrators to log in, and that administrators can revoke accounts by users, and can get rid of malicious users who are trying to go there for purposes of eliciting private information, etc. This notion is just not in their heads. Just like the notion that you need a server-side set of components, or you need connectivity for phones to be able to stay in sync with each other, is just not in their minds. So you have to make sure that you're eliciting, you're thinking ahead about, okay, what might be needed, and asking questions about how are we going to deal with a situation where this changes. Yeah, so question.
So for the UI testing,
yeah,
we want to do it manually and automated.
Correct. Yeah.
So automated just to test the actual functionality and manual to like,
That's-
how does it make you feel, or like, is it intuitive?
Well, so there's that component of manual testing, which is about usability and kind of user experience.
Yeah.
And that's very important for end user satisfaction in many cases. But there's another component of manual UI testing that's extraordinarily important, and that is exploratory testing, okay? So when you folks have a bug party, and you should have a bug party early and you should have them often, because they are a lot of fun and they're a lot more effective. 20 people in a bug party together, or say 10 people in a bug party together, are a lot more effective than those 10 people for the same amount of time independently, because they learn from each other. And really, exploratory testing is about putting the system through its paces and trying things out manually. And you often notice things when you're doing that, like, oh, it's slow here. It's reacting in sort of strange ways here. It seems to be kind of flaky in terms of showing this information. It's off the screen or what have you, or on my small device, it's not showing up properly. By doing things in an exploratory way, it often clues you into areas of the system that are soft, like that aren't that are suspicious, and you can then like push on those more with automated testing and like going into those areas and really banging on the system. You can also try things that are very much stimulated by your observations. So you notice that it's slow for updating a field, that even when you specify a small bit of information. So maybe you paste in a big bunch of information and see if that causes it to be even worse. Or you notice it's slow with even just a few users, and so it stirs up the idea of trying it with 50 users simulated on the system or something. So in short, UI testing, it's very valuable for automated. A limited number of tests can run in the build. It's very valuable for exploratory testing, and it's valuable for user experience testing. Okay, but those are kind of different uses of it. Beyond that, non-UI testing is absolutely essential. When I say non-UI testing, does the term test harness mean something to you? Okay. So, did you folks apply in 270 or 370? Did you apply JUnit? NUnit?
I think if they used it in their project, they would have 270.
Mm-hmm. So what testing frameworks are used in 270? JUnit. Okay. So some people must have seen some of JUnit. And probably what you were doing mostly there was unit testing. That's the unit in JUnit, right? But the fact is, we can use those same technologies to do what industry calls system tests. Okay, system tests are basically not just testing of a small piece of the system, but you might test certain functionality of the system across the system, across many modules of the system at once. Like you test a feature of the system, not through the UI, but by calling it. Because after all, when you press buttons in the UI, you're calling methods to get the work done. So all you do is you call those methods directly from the JUnit code, the code in the text. And when I say a test harness, that's what I'm talking about. Harness, because you got to kind of set it up. You got to kind of set the system up to get in the right state to run the test. So maybe you load in a file with one set of calls, and then you have it, perform searches on that document by subsequent calls in a loop, right? It does search and replace, and then you confirm that it's been done, and then you sort of tear down the stuff you set up for the system. And so set up and tear down code is often done in these test harnesses where you're kind of getting the system ready to test it. And here you're testing large areas of the system, not just a little wee piece of a system like a function or a method or one, two methods of a class. You're actually testing, search and replace, and that calls off to dozens of methods to accomplish its goal. But that's just the point. And why would you do this sort of user testing in addition to UI testing? This sort of automated testing in addition to UI testing. Why would you do it? Why not just do everything through the UI?
Slow.
UI testing is slow, and UI testing is fragile. Why do I say fragile? It's gotten less so over the years, but it's still pretty fragile. So, yeah.
If it's change in a component or interface, it automatically fails.
Yeah, darn right. And let me say this, for a fair number of systems out there, the user interface evolves actually quite a bit quicker than the underlying business logic. You're working in a similar area, business logic stays pretty similar over time. Pretty similar. I mean, it evolves, but it's pretty similar. You're dealing with banks and accounts and transactions, and 5 years from now, you're going to deal with banks and accounts and transactions. Things will evolve a little bit. You'll have, different ways of maintaining this. Technology will evolve a little bit, but the fact is, the business logic doesn't typically evolve as quickly as the UI, and so UI tests break much more quickly than tests of the underlying functionality, typically, because they're dependent on UIs that change. It used to be really bad when you folks were young, when you folks were younger than you are now. When I was young, okay, and I know you think all I had was ones and zeros. When Mark Kyle was young, you think all he had is zeros. No. The truth is, even just like 10 years ago, UI testing was pretty hairy. We did a lot of it. I mean, they've been doing a ton in industry for 2 decades now. The problem is it depended on pixel level measurements sometimes. Like you had to say, click here, at this pixel. And so if the dialog box came up even slightly shifted, or the button on the dialog box was moved because this text field grew, it would miss. And then it wouldn't press the button. Then the test would fail. And well, they wouldn't cry, but it would be a pain. So you'd have to go fix the test. These days, it's more robust, but you still have to evolve it. If you split the dialogue into 2 separate dialogues, or you add a new screen to your app or something, chances are you have to fix the UI test. But I digress. Okay, so ladies and gentlemen, you will notice ambiguous words sometimes in these write-ups of requirements. So maybe it says it should be done quickly. Okay, let's understand what quickly means. So the item, upon invocation of the search functionality, the item will be quickly returned to the user. Okay, does that mean within 30 seconds? Does it mean within 3 seconds? Does it mean within 1 second? It may sound overly picayune, but you want to make sure you're in sync with the stakeholder. You don't want them thinking they mean 1 second, and you're thinking 30 seconds is fine, because they may be an unhappy camper, right? Another thing is if words have multiple meanings, or if you have a sense it's a term of art in their field, they're using this word, you don't quite know what it means, ask, and ask it for it to be rephrased in common parlance, in kind of common terms. Okay. You might describe multiple views of the same underlying requirement. Say, provide a couple descriptions of it for better understanding, or drawings of it. And this is important. Try to have in place a requirements change process. This used to be really big. When when I started teaching this class, 12 years ago, requirements change processes were huge because particularly for non-agile processes that didn't involve a lot of iteration, handling requirements changes was key. Why would that be? Suppose you're working 6 months for a deliverable. Microsoft Office and other things like the LibreOffice suite and so on, a lot of systems like that, they're hard to iterate as quickly because all the pieces have to come together. You have to have the new version of Excel, and the new version of Word, and the new version of Access, and the new version of Outlook or whatever, and they all have to play nicely. And functionality one has to be supported by the other. Sometimes you can paste things in or whatever. And so even there, like for Word, I think you're still getting slower delivery cycles. So why would requirements change management be such a big deal there? Yeah.
Because the cost of changing it grows exponentially, and if you can keep it cheap at the start, it's good.
Okay, so I like that. If you change a requirement later, yeah, it affects a lot of things. And as I drew a diagram last time, I think exponential growth in the cost of correcting something later in the game. Okay, because you have to throw a lot of stuff away. Yeah.
Having a process of changing the requirement beforehand will make the actual changing the requirement a lot faster than actually trying to figure out a plan on the go.
Good. And that's kind of a contingency plan strategy, right? You know what strategy you're going to follow. So when this comes up, not everyone has to meet. You don't have to have a full group meeting just to talk and, how are you going to handle this, et cetera. You have a strategy in place, a process for handling it. So that's good. I really like that. But there's another reason, too, that maybe it's so obvious to me you're not saying it. So obvious to you, you're not saying it. The fact is, if you have these long delivery times for things, a lot can happen to the client during that time. During that 6 months, things may happen. Not quite empires rise and fall, but it's pretty significant changes in the client side. Okay, didn't get that one. So the fact is, in 6 months' time, user needs may actually evolve quite a lot. More to the point, perceived user needs may evolve. The bank you're doing IT for could merge with another bank. The way reporting is done within the organization undergoes changes. Now they need these extra fields, what have you. And if you don't have a requirements change process, you're going to get potentially henpicked to death all along that 6 months. Because they're going to say, well, something changed, I'd like to have this, I'd like to have that. And if you don't have a formal way to handle it, those things just leak into the process. I remember one of my first jobs as a software engineer, not my first, I'd actually been doing it at least for 5 years then professionally, but I remember getting called up by clients who wanted certain changes. And they knew where to call. They know I'm the one doing the work. And so call up, I really want this, I want that. And they're on my case. They're, just going around and hounding me some about this. Sometimes they call a few times a week or something. And I just want to get them off my case. Say, yeah, sure. But I should have gone through the project manager, because the project manager actually knows what they're paying, if they need to be paid more. Maybe they're really underpaying for their contract, in which case he could go back with a strong case and say, look, you want this change, time to talk about more money, or time to talk about more time. He's the one who can take a view of all the different developers and say, wait a minute, we're getting a lot of change requests. Let's batch these up, or let's prioritize them. Maybe my boss, maybe she's the one who knows what we're going to be working on next for another client and says, this is important to this client, but we're keeping this other client waiting. And maybe she says, look, all these change requests need to go in the next contract, not now. In short, you got to have a process for going through and changing requirements, particularly if you have a long delivery time, because a lot can change during that time. I remember one company that I was consulting for, one of my first consults professionally. I went over and met with this company for a week to diagnose what was going wrong. And one of their key things is they were just getting changed to death. They'd be starting out working on this project, and then they get a change that significantly altered it, and get a change to that, and they never got to where they were going because they were always being pushed to different sides, and the customer was getting more and more unhappy, and the more unhappy they got, the more changes they requested, because after all, they're not delivering us product. Let's at least get a product we want. So another change request, and then the developers are just overwhelmed. They're not being able to deliver it, and they get another change request, it gets them further in trouble, etc. Okay. So sources of error, missing requirement is key. You can get this under very different circumstances, as I noted. Problems with recall, problems of observational error, you misheard the statement, missed ambiguity. All of these go into have multiple people there. They will recall it differently. They will hear different things, potentially. They will repeat it back, think to repeat it back when you didn't. You'll miss an ambiguity that they notice. They may notice, well, why didn't they talk about this? Is it not needed or not important or just too obvious? So another common source of error is you completely neglect tacit sort of requirements that are implied for other areas. So performance, scalability. They may think, well, of course it has to handle thousands of people. I mean, don't you know the patient volumes we get in RUH? Well, no. You don't know the patient volumes. They do. And they assume you do. Or it has to be secure. They just assume, well, yeah, of course it has to use U of S login. It needs to be able to handle attacks in such and such a way. Whole types of administrators. I said, this is a really important one. Okay, you're working on a great new system for them. Great. Maybe they've got an existing system. What they often won't mention, or sometimes won't mention, is something that takes a huge amount of time, and that's cut over between the two systems. So you have the old system, it has all sorts of data. You have the new, much better, spanking new, shiny system, and you've got to bring data from the old system to the new system. What's worse is that data has to be brought really quickly. Why? Because you want to cut over from the old system to the new system in like a day. You want to be able to go, stop using the old system and go to the new system. If you can't, if that process takes a long time, then they're using the old system with it. And now you have to get more data over. And it's not converging, and it's not a neat process. So often you want that to occur over a holiday or a weekend or what have you. But you can't leave it up to chance. You got to get it in place. Okay. Right. Ambiguity tests. Ask for restating of problem statements or requirements by parties at requirements meetings. Restate things or ask them to restate it. And you can ask them to define words. What do you mean by this? What do you mean by that? Or ask them to use colloquial words. I give a bunch of examples in here drawn from my experience, from industry, etc., from books that you might want to consult that give some ideas here. But the most important thing is just be conscious there are these dangers, have multiple people there, cognizant of those dangers, and undertaking some basic actions. Ask them to restate it, restating it yourself and seeing if they agreed to it, writing it down, asking them to prioritize, making sure you're thinking about things they're not going to be thinking about, like administrative interfaces, like performance needs, needs in terms of connectivity how it can handle cases where they're not connected, etc. Users often think of the typical case. They're thinking about the app functionality when everyone's connected nicely, and you've got to ask, well, what happens when we're not connected? We can't connect. What does the app need to do then? So you need to be consciously aware that users often omit a lot of things in their mental model, and it's up to us as software developers to work to fill in those gaps and to make sure that our understanding is in line with, grounded by the user. Okay? So, ladies and gentlemen, we are going to reconvene in this room at 4 p.m. And we'll hear some from you about your infrastructural plans, some of the technologies that you'll be using. And this is a chance for me to understand your plans and to provide feedback. Because there's 4 teams this year, we're going to probably have to leave some of the feedback for emails. And I will ask people to see if you can bring in, if possible, either a thumb drive to use it on this computer, or bring in your own laptops and come a few minutes early to test them before the time so you can quickly switch, okay? Because it's going to be very tight time-wise. Yeah?
In the on the syllabus, it says that all would have to be within the 1 hour